Hi guys, Tony Josephs here. Welcome to my technology channel. Guys, I need your support, so please subscribe to my channel. Can't do without your support, guys. Appreciate it. Hope you guys are doing well today. Before I get into this very interesting topic of encryption and how we can use encryption to protect our confidential and sensitive information / data. Okay, here it goes. You can look at encryption like you have the keys to open your front door to get into your house. And you use those keys all the time. What if those keys got into the wrong hands? When you're not around, somebody else uses those keys to open your front door and to take all of your precious belongings. You come home to find your house pretty much cleaned out. You've been compromised. Somebody came into your house and stole all of your valuables. Same concept here. Somebody can break into your computer. They can get into your computer. They could break your password by using brute force techniques to break your password and get into your system. Access your hard drive, which has all of the information on you about you, your credit card, your banking information, marriage license. Your whole life is on your system. They can steal that information and take it, impersonate you, get into your bank account, and steal all of your money. Yeah, that's real life identity theft. So to prevent that from happening to anyone out there on this planet, in this world, globally, internationally, domestically, we have to use encryption. And encryption is a way of, like I mentioned, encoding plain text information, which could be a social security number or banking information, into ciphertext, which is scrambled information that people cannot read what is actually there. This information is scrambled. They cannot interpret it. So that process of encryption will help to protect and secure your data from eavesdroppers and interceptors that are out there lurking, waiting for the opportunity. Yeah. So that being said, that same person that has encoded the information from plain text into ciphertext can decrypt it back from ciphertext back to plain text. He has the keys to do so. He has the keys to open the door to do so. Only he can do that. That's the unique thing about all this. Protecting your data. This is the best move to secure confidential and sensitive information such as credit card and social security number and banking information. It's not easy to stay on top of everything. Having good passwords can help. Also, encrypting your hard drive can help in case they try to steal your hard drive. They can steal it, but they won't be able to read the information that's on your hard drive. Yeah. So that's another way of protecting your data. If your laptop is stolen, your hard drive is encrypted so they won't be able to read or interpret anything that's on your hard drive. That's another way of protecting yourself. Okay, let's move on. The different levels of encryption. You have database level encryption, you have file level encryption, you have storage level encryption, and you have application level encryption. So let me start from the bottom. Storage level, file level, database level, and application level being the highest. Don't mean to confuse you, I apologize. So all of these are considered encryption to protect data at rest, which uses one key, asymmetric key, which is AES 256-bit, Advanced Encryption Standard, AES 256-bit. That's what is used on storage systems, file level systems, database level systems, and application level systems to protect your data at rest. For instance, if you have a database, such as a Microsoft or Oracle database, that maybe uses transparent data encryption, or it may be using column level encryption, where your information is in various columns, maybe social security number information, banking information is in certain columns. Those columns will be encrypted. You have to have special access, maybe some role-based access to be able to see that information. And you can minimize the access for people who you want to see by using RBAC, role-based access control, to do so. This is just using one key, a symmetric key, to encrypt and decrypt. AES 256-bit. So remember that. Now, if you're on the encryption in transit side of the house, which will use Hypertext Transfer Protocol Secure, HTTPS, which uses port 443 to make sure your information is being communicated securely over the internet. HTTPS will use, that's a protocol in itself, it will use Transport Layer Security, which is another protocol, to protect your data in transit. It may use TLS version 1.2 or TLS version 1.3, which is a lot more secure. It uses better ciphers for security. That was a lot that I mentioned. So if you were to check your web page or your website and look for that lock, it will show that HTTPS is using port 443 and it's enabled, and you're communicating securely over the internet. If you don't see that, that means by default you're using HTTP without the S, which uses port 80, and you are not secure, my friends. If you see that, that is a no-no. You'd want to change that immediately to HTTPS, which uses port 443, which shows that you are communicating securely over the internet. That's a big point. And you should double check your home system, corporate systems, to make sure that is enabled. Okay? Hypertext Transfer Protocol Secure is where you need to be, which uses port 443. And HTTPS uses Transport Layer Security Protocol to send your information securely over the internet. The two keys that TLS uses is a public and a private key. This is considered asymmetric communications. Asymmetric because it's using two keys, a public and a private key. Make sure you understand that. And it also uses RSA 2048-bit certificates to send your information from site to site. That's a lot, I know. Forgive me. All right, so you may have people there on your certificate management team, and they can verify that what is the bit size of the certificate that's being sent securely. All right, your symmetric key, which is going to be for data at rest on your storage systems, in your database, and in your applications, uses one key, a symmetric key, to encrypt and decrypt. That's the difference. Data at rest uses AES 256, which is a symmetric key, which uses one key to encrypt and decrypt your information. All right? That's the way to make sure that your data is protected securely at rest on your storage systems, file level systems, database, and application systems, and in transit securely over the internet using asymmetric communications doing 2048-bit RSA. which has a public and a private key. That's the difference. That was a lot, guys. Sorry for that. But anyway, just want to mention that encryption is not new. It's been around since ancient times. In Caesar's time, it existed. So it's old. It's an old technique. It's an old mathematical substitution technique. The Caesar cipher has existed since ancient times. Modern day times, we have the Enigma machine. The Enigma machine, which was used in World War. I think World War I or World War II, one of those World War. Militarily, it has been used. Also, Morse code has been used to send information securely so other folks won't be able to interpret what you're saying. Okay? And we've had other flavors of encryption, such as the Jefferson wheel. So you can look all of this up when you have time. But the point being, we should protect our data at all times from eavesdroppers, intruders that want to steal our information. Your banking information, your social security number, credit card information, and your marriage certificate, driver's license, and other confidential information such as your medical health records. People want to see what you're all about. You know, identity theft is a known problem, and this is one way to squash all of that from happening to you. You need to protect yourself. Don't leave yourself wide open, folks. There are thieves out there waiting for this information, so encrypt your password, encrypt your hard drive, encrypt your laptop information. Use encryption wherever you can to protect and secure your confidential and sensitive information. I know this was a tough subject, not the most easy topic to discuss, but the point being, I hope that I did give you guys some good information that you can utilize. Encryption at rest and encryption in transit. Encryption at rest uses symmetric keys. A is 256-bit. Encryption in transit uses asymmetric keys, 2 keys, a public and a private key to send your information. Hope that helps you guys in some way or another. Always use password protection on your laptops. Always encrypt your hard drive using AES 256-bit in case somebody tries to steal your laptop. The information on your laptop would be unreadable to them because it will have the ciphertext, which most people that I know of can't read. Yeah, that's all I have right now on encryption. And we'll discuss more on this topic in the near future. Hope this helps you guys to secure your confidential and sensitive information at all times. Use good passwords and use encryption at all times. I'll talk to you soon, guys. Have a good one. Please subscribe. See you later.